So we're going to look at some more transformations of radical functions today. So the goal on these is to describe the transformations first, sketch a graph, and then use a convenient point to have some nice scale on that graph that you don't get from your calculator. All right, so number one, can you guys tell me what transformations are going on in number one? Inside plus 5 is going to be left 5, yep. What else? Up by 4, even if it's in front? It's not multiplied, right? So it's not a stretch or compression. So this is up 4. Anything else? This is going to be reflection, right? Reflection up or down since it's outside. So we're going to say reflected down across the x-axis, something like that. Cool. All right, so let's graph it. So let's see, left by 5, and up by 4, shape, cube root, flat, horizontal snake shape, except we're supposed to reflect it how? Down. So should I just reflect it like right here? How do I reflect this thing down? So like where should I start drawing? So should I like put this point down here?
Yes.
Okay. So 1, 2, 3, 4. And then instead of going that way, I should go that way. Instead of going that way, I should go that way. And now we'll put a point on there for scale, and also just to make sure we didn't make a mistake on this one, because that reflection was a little weird, right? So let's make sure we didn't make a mistake by picking a point. So what would be a nice point that should come out nice? If we go like alpha of what? What would come out nice if I put it in right there? 3? 3 would make that 8. Nice. So I think 3 is a good choice. So that would be 4 minus the cube root of 3 plus 5 is 8. We know the cube root of 8 is 2, so that's 4 minus 2 is 2. So at 3, you're supposed to be at 2. Does it look like we're at 2? Not close. Not even close.
It's
Kyle.
because you made it negative 4 minus the cube root of x plus 5 instead of just 4.
Ah, this is a problem where the order of the transformations actually occurs and has an effect, right? If I'd have said reflect it after we'd moved it up there, we'd be good to go, right? Because then I'd apply the negative not just to that part, but also to the other part, the 4, and I think that's what Kyle was saying. But in fact, this is kind of more like move it left by 5, then flip it over, and then move it up. That negative was never applied to the 4. It was just applied to those other things. You guys remember those problems we saw where the order of the transformation matters? This is one of them, where it's easy to make a mistake. But see how the point that I'm having you guys do is not just for scale, it's to save you as well and help you hopefully figure out that order issue and not make mistakes with it in the future. That's the main reason I'm having to do it, really. So let's fix that. So it should be up here, which is of course still flipped over. It's just flipped over before we move it up. Okay? So that one is a little bit sneaky. Number 2, beta. So I did alpha, beta, gamma. My gammas always look weird. It's not y though. Okay, so what's happening on beta? Beta has a sneaky transformation. So the first thing you should do is identify that sneaky transformation, because inside there's more than one thing happening. You've got the 2 and you've got the minus 4. So immediately, if you see that there's more than one transformation inside, you're supposed to what? Factor it, otherwise you're going to get tricked. So definitely want to factor that guy first and say this is 2 times x minus 2. That's what beta is here. So this guy is going to be, I'm just going to say it, I'm not going to write it, it's getting our stuff cluttered. It's down 8. right by 2. And this guy, is it going to be like a stretch or compression? Let's just go down 8, right by 2, and we'll kind of figure that out with a point, and then we'll talk about it, I thought, for this one. Okay. So, square root shape, our launch pad shape, right? We're going to go right by 2, down by 8. 3, 4, 5, 6, 7, 8. Launch pad shape. There we go. Did I draw mine too steep or too flat? I don't know. Let's pick a point and see. So beta of, what would be a nice point to plug in? You could look here or here. If you plug in 4, you're going to get 8 minus 4 is 4, which will come out nice. I like that. That's a good choice. If you plug in 4, you're going to go square root of 2 times 4 is 8, minus 4, minus 8. So that's going to be square root of 4 minus 8, which is, of course, 2 minus 8, which is negative 6. Let's see if mine looks good. At 4, we're supposed to be at negative 6. This is negative 5, so like negative 6. Mine actually looks pretty decent. Let's talk about whether that 2 was a stretch, a compression. Is it a horizontal or vertical persuasion of those, though? Horizontal, because it's inside. Inside stuff. Is it what we expect or not? It's opposite. So you should expect multiplying to be stretchy. But inside is opposite. So instead of horizontally stretching, I'm going to compress this curve. Imagine that launch pad shape, or any other shape, if you will, that gets smashed like this. What's going to happen? It's going to get steeper, exactly. And mine looks pretty steep, actually, for a square root launch pad shape, so that's why I think it was good to go. Okay? So there's that guy. Transformation time. All right, gamma. So gamma of x. I think this one's a little easier. Let's go down here. Got an up 3, and we've got both kinds of reflections. So I'm just going to say flip both ways to be brief. Launch pad shape, and you should be good. Okay, so we're going to go up by 3. Think about our launch pad shape, but it's going to be flipped. This one's going to flip it down. This one's going to flip it sideways. So I think it's going to be this kind of shape. Now let's think about order. Was I right? You could, of course, check me on your calculator. Why don't you guys check me real quick? Use your calculator. Let's see if that looks right. So if you're watching the video right now, I'd recommend that you check me. And you might as well go back and check this one as well. Just check it on your calculator. And see if, I mean, is it right by 4? If the instinct on this problem was to think that it was right by 4, but I think if you put it in your calculator, you're going to see it doesn't move quite 4 over, it's only 2 over. So was I right on this one, or did I mess up the order of the transformations? I think the transformations are good, but do I have them in the right order, kind of? So I think it's kind of like you flip it that way, you flip it this way, and then afterwards you kind of move it up 3, because that positive 3 doesn't have like a minus on it or anything, right? So I think we're good. Hopefully you guys saw the same thing. So let's put a scaling point. The scaling point should be super easy on this one. It'll be a nice value to plug in. I don't want 2 to come out again. Let's do something different. It'll be a good thing to plug in this time. Negative 9, negative 4. I was getting tired of 2, so I'm going to go with Logan's. If you plug in negative 9, I thought negatives made imaginary numbers in square roots. Oh, okay, so it's going to go minus, 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 plus 3, so that's going to be negative square root of 9 plus 3, which is negative 3 plus 3. Logan has spotted the x-intercept. That's pretty nice. So at negative 9 now, so does that mean my blue curve, is it too steep or too shallow? It's too steep because it's supposed to be like 1, 2, 3, 4, 5, 6, 7, 8, 9. These kind of shapes, radical shapes, grow really slowly unless you like stretch them with some kind of extreme dilation. Okay, so there we go. Last problem for us today is this one. So we got a parent function being the horizontal snake shape, the cube root, and we're supposed to reflect it across the y-axis first. Notice this has an order. Then I'm supposed to compress it vertically by a factor of 7, And then finally, I'm going to move it down by 15. So I'm going to produce a new function, so we'll call it g. I'm not going to graph this guy, I'm just going to write it down. So, reflecting it across the y-axis, what's that going to do? What do I have to put in g? I'll get a cube root going. What am I going to have to do with my cube root to make it do that? Negative where, Josh? Where? Which way are we flipping it? Y-axis. See, this is always interesting. I always get flip-flopped there. So y-axis is like this axis or this axis? It's this axis, right? So what am I flipping it? Horizontally. So where should the negative go? Yeah, so we're going to say negative inside. Get some of this other stuff out of the way just to remove some of our clutter. Okay, so negative inside. I'll just put an X in there for good measure. Then, I'm supposed to vertically compress it by 7. Well, it's vertical, so that should be outside, right? Like multiplying stuff, adding stuff, what? Multiplying stuff. So like 7? That'd be stretching it, so it really, they must have meant this, right? Okay, so that's done, sweet, good to go. Finally translated down by 15, where should that be? Outside, so I guess I can end this square root and just go minus 15. And we're good to go. The only order issue I think you'd have on this particular problem is if by chance it had said do the down 15 in the middle, and then it said compress it vertically after that, because then you wouldn't just apply this 1/7 to this piece, you'd also have to apply the 1/7 to the 15 piece. So that could be a little bit subtle. Now I did some little bit tough problems with you today. I think this should be more than enough for you to handle anything that your assignment throws at you. Okay? We'll see you next time.